3 is graphing techniques. So you follow certain things in order for you to, well, graph experimental data. So a well-designed graph will quickly and easily represent a huge amount of information. So we can actually define a graph. So a graph just represent, it represents visual representation. It represents visual representation of the relationship between variables. Okay, so visually you can see the relationship of two quantities by using the graph. That's why, again, you can analyze it much clearly, comparing it with you just have a table. Okay, so there are certain things that you need to remember when you try to graph your data. So first things first is you need to identify your variables. Okay, so it is a general rule that the independent variable is plotted along the x-axis. So remember that in a Cartesian coordinate plane, it is consists of x and a y, wherein the common point of intersection is the 0 or the origin. So when you plot your variables, it must be that the x-axis would represent your independent variable. So whatever is your independent variable, it should be plotted here. So if you will be asked, how would I know in a particular experiment that my variable or that particular quantity is my independent variable? So actually, the independent variable is the variable that is changed in the experiment. Okay, so let's say, for example, if you're going to study the motion of a particular object. So in your procedure, let's say, for example, you're going to take or you're going to measure the distance covered by the object every 1 minute. Okay, so every minute you take or you measure the distance. So in that particular case, given the procedure, the independent variable is the time, because you're changing the time. And the dependent variable, on the other hand, should be plotted along the y-axis. So therefore, this should be the dependent. Dependent variable is plotted in the y-axis. Okay, so one way of looking at the dependent variable is that it is the variable that is being measured. Okay, so for the time, as I mentioned in my example, if you want to study the motion of the object, so you're taking or you're measuring the distance of the object covered by the object every minute. So you set that one, no need to take the time, because you try to, again, measure the distance every minute. So you set that one. So the independent variable is the time, and the dependent variable is your distance. So the one that is being measured in your experiment. Okay, so after you identify the independent and dependent variable, determine the range. You might be thinking about range as just the y values, but the range only means that what would be your minimum and maximum values. So the minimum values and the maximum value of each axis. And since graph is a visual representation of the relationship between the two variables that you are examining, so in my example, distance and time, so you need to make a graph that is big enough. So that is why it is advisable to use at least 3/4 of your graphing paper. So this could be anything of your screen. So there's no point of having a very small size of a graph. Okay, because the purpose of the graph will give you a visual representation or the visual thing. So if you cannot, if you have a very small one, well, that defeats the purpose of your graph. Okay, and next up, don't forget to label. Okay, and the numbers to both axes and the units. So let's say, for example, in my case, if I'm studying distance over time, so I'm gonna place distance and then the unit m. So let's say it is in meter. So take note that the unit is placed in brackets. My x, since based on my experiment, time is my independent variable, so I place time, and then let's say I mentioned about minute, so the unit should be in minute. So again, I'm gonna place it inside a bracket. Okay, and then let's say I have these data points here. If you can remember your plotting, it's also the same thing as plotting in your math. So let's say I have data points here. Okay. So let's say, for example, these data points, if you can see, it is not necessarily all the data points will fit in a single straight line. However, when you try to draw your curve, you have to remember that just draw whichever is fitting of the general trend of your data points. So in this case, if you can see, well, all of them are increasing, so that represent a straight line. But remember that that is not always the case, okay? That is why you need to remember that no need to connect the dots. So do not connect the dots. Okay, so therefore, let's say if you have decided that it is a straight line that would best represent my data points, so draw a straight line. So you can use a ruler. So a ruler, and if you can see, doesn't also have to start at 0. So just draw a line that could represent all your data points. So for example, in my case, yeah, this would be the best one. So I can draw that one out. So if you can see, my straight line doesn't hit all the data points, and that is correct. Again, do not connect the dots. Again, just try to examine what would be the best curve that fits your data points. So if it's a straight line, draw a straight line. If it is a quadratic, draw a quadratic form. If it is radical, so you draw a radical function. And then lastly, you need to add a title. So the basic title is just the, well, in your case, you're plotting the distance versus time. You can just place distance versus time graph, distance versus time. Okay, so the y variable and then the followed by the x variable. So I can write it that way, distance versus time. So that's the title of my graph.